Hi, welcome to Professional Certifications channel. Let's break down CISSP exam preparation, one topic a day for focused and effective learning. Today's topic is Data Loss Prevention, DLP.
Definition. Data loss prevention, DLP, refers to a set of technologies, tools, and processes designed to detect, prevent, and protect sensitive data from being lost, leaked, or accessed by unauthorized users. DLP systems monitor, detect, and block the unauthorized movement or use of sensitive information, such as personally identifiable information, PII, intellectual property, IP, financial data, and health records. DLP Solutions help organizations enforce data security policies and comply with regulatory requirements.
Key concepts.
1. Purpose of data loss prevention, DLP. The primary purpose of DLP is to prevent the accidental or malicious loss or leakage of sensitive information from an organization. DLP solutions ensure that data, whether it is in use, at rest, or in transit, remains secure and is only accessible by authorized users or systems. DLP is commonly deployed to protect sensitive data such as credit card information, social security numbers, intellectual property, and health records, which are subject to strict regulatory requirements and compliance.
2. How DLP works. DLP systems work by monitoring and inspecting data flows within an organization and comparing them against predefined security policies. If an action violates a policy, e.g., sending sensitive data to an unauthorized recipient, the DLP system takes action, such as blocking the transmission, alerting the user, or notifying the security team. Key functions of DLP. Data discovery and classification. DLP systems scan and identify where sensitive data resides across an organization, whether in databases, file servers, endpoints, or cloud storage. This enables the organization to classify and protect sensitive data. Policy enforcement. DLP systems enforce security policies based on predefined rules. These policies dictate what types of data are considered sensitive, who can access the data, and where the data can be transmitted or stored. Content inspection. DLP solutions inspect the contents of data files, emails, attachments, and other forms of communication to detect and block sensitive data before it leaves the organization. User monitoring. DLP tracks and monitors user behavior to identify and prevent potential insider threats, such as employees attempting to exfiltrate sensitive data. Example: a company implements a DLP policy that prevents employees from sending emails containing credit card numbers outside the organization. If an employee tries to send an email with a credit card number, the DLP system detects the sensitive data and blocks the email from being sent.
3. Types of DLP solutions. DLP solutions are typically categorized based on where they are deployed and what they protect. Network DLP, NDLP. Network DLP monitors and controls sensitive data as it moves across the network. It inspects data in transit, e.g., emails, file transfers, or web traffic, to detect and prevent unauthorized data transfers. Example: Network DLP scans outgoing emails for sensitive data, such as personal information or financial data, and blocks emails that violate the organization's data security policies. Endpoint DLP, EDLP. Endpoint DLP protects sensitive data on individual devices, such as laptops, desktops, and mobile devices. It monitors and controls data in use on endpoints, e.g., copying data to USB drives or uploading data to cloud services. Example: Endpoint DLP prevents an employee from copying confidential customer data to a USB drive or sharing it via personal cloud storage accounts. Cloud DLP. Cloud DLP solutions are designed to protect data stored in or transmitted to cloud environments. These solutions help organizations monitor and enforce data security policies for cloud-based applications and services, such as Google Drive, Microsoft 365, or AWS. Example: a cloud DLP solution monitors data uploads to cloud storage services and blocks attempts to upload confidential files to unauthorized cloud accounts.
4. Data states protected by DLP. DLP systems protect data across the three major data states. Data in motion, data that is actively being transmitted across a network. DLP inspects network traffic, e.g., emails, file transfers, to prevent the unauthorized transmission of sensitive data. Example: DLP blocks an email containing PI from being sent to an unauthorized external recipe data at rest, data stored on hard drives, databases, file servers, or cloud storage. DLP scans stored data to ensure that sensitive information is properly secured and not left in unprotected locations. Example: DLP identifies and flags unencrypted financial records stored in a public folder on a file server. Data in use, data that is actively being accessed or processed by applications or users. DLP monitors user interactions with data on endpoints, such as copying, printing, or uploading sensitive information. Example: DLP prevents an employee from copying sensitive financial data to a USB drive or sharing it via a personal email account.
5. Content detection techniques. DLP systems use several techniques to detect and classify sensitive data. Pattern matching. DLP systems use predefined patterns, e.g., regular expressions, to identify sensitive information such as social security numbers, credit card numbers, or bank account details. Example: DLP detects a string of numbers that matches the format of a credit card and flags it as sensitive data. Keyword matching. DLP scans content for specific keywords or phrases associated with sensitive data. This method is often used for detecting intellectual property or confidential documents. Example: DLP identifies documents containing phrases like confidential or proprietary and applies security controls. Fingerprinting. DLP can create fingerprints of sensitive documents, unique digital signatures, and monitor for attempts to copy, send, or move those documents. Example: a DLP system detects when a sensitive financial report, fingerprinted by the system, is copied to an external drive. Exact data matching. DLP can compare data against a database of known sensitive information, such as employee records or customer databases. Example: DLP detects attempts to transmit employee social security numbers by comparing them to known values in the HR database.
6. Advantages of DLP. Prevents data breaches. DLP solutions help prevent accidental or malicious data leaks by monitoring, detecting, and blocking unauthorized transmission or access to sensitive data. Insider threat protection. DLP protects organizations from insider threats, whether malicious or unintentional, by monitoring user behavior and restricting the unauthorized sharing of sensitive information. Compliance with regulations. DLP helps organizations comply with data protection regulations, such as GDPR, HIPAA, PCI-DSS, and SOX, by ensuring that sensitive data is properly handled, stored, and transmitted. Data visibility. DLP provides visibility into how sensitive data is used, accessed, and shared within an organization, enabling security teams to identify risks and enforce policies.
7. Disadvantages of DLP. False positives. DLP systems may generate false positives by incorrectly flagging non-sensitive data as sensitive, which can disrupt business processes and lead to user frustration. Complex implementation. Implementing DLP solutions can be complex, requiring careful planning, policy configuration, and integration with existing security systems. Misconfigured policies can lead to gaps in data protection. Performance impact. DLP solutions, particularly Endpoint DLP, can impact system performance by monitoring and inspecting all data activities, especially on high-traffic networks or busy endpoints. Limited protection for encrypted data. DLP systems may struggle to inspect and control encrypted data, especially if they lack the ability to decrypt traffic.
8. Common use cases for DLP. Protecting intellectual property. Organizations use DLP to prevent the unauthorized transmission of intellectual property, such as proprietary designs, source code, or trade secrets. Example: DLP prevents an engineer from sending confidential design documents to an unauthorized external email address. Ensuring compliance with regulations, DLP helps organizations meet regulatory requirements by monitoring and controlling the transmission of sensitive data, such as health records, HIPAA, or payment card information, PCI-DSS. Example: a healthcare provider uses DLP to ensure that electronic protected health information, EPHI, is not sent to unauthorized recipients, helping the organization comply with HIPAA regulations. Preventing insider threats, DLP Solutions monitor user behavior and detect suspicious activities, such as copying sensitive data to personal devices or emailing confidential information to personal accounts. Example: DLP blocks an employee from copying sensitive customer data to a personal USB drive.
9. DLP and Regulatory Compliance. DLP Solutions help organizations comply with data protection regulations by ensuring that sensitive information is securely stored, transmitted, and accessed. Some key regulations include GDPR, General Data Protection Regulation. DLP helps organizations comply with GDPR by monitoring and preventing unauthorized access to personal data and ensuring that data is handled according to privacy rules. HIPAA, Health Insurance Portability and Accountability Act. DLP protects health records, EPHI, by monitoring and controlling their transmission and ensuring compliance with HIPAA requirements for data protection. PCI-DSS, Payment Card Industry Data Security Standard. DLP ensures that payment card data is not transmitted or stored in an unsecured manner, helping organizations meet PCI-DSS requirements.
Importance in the CISSP exam. Data loss prevention (DLP) is an important topic within the security operations, asset security, and identity and access management (IAM) domains of the CISSP exam. CISSP aspirants must understand how DLP solutions work, how they help prevent data breaches, and how they support regulatory compliance. Exam questions may focus on DLP use cases, data classification, and how DLP is integrated into an organization's overall security strategy.
Real-world example: a financial services company uses DLP to protect customer financial data and ensure compliance with PCI-DSS. The DLP solution monitors emails, file transfers, and network traffic, preventing unauthorized employees from sending credit card information or sensitive customer data outside the organization.